Okay, let's give you guys some practice. So find the limit of this as x tends to 0 from the positive direction. So press pause and have a go. Okay, so if you try and plug 0 into here, 3 times 0 would be 0, plus 1, this whole thing here would be 1. Put 0 into here, this will head towards infinity. So here we have an indeterminate power. It is something that we're familiar with. Remember, you can have 0 over infinity, you can have infinity over 0. Any of these forms here, here you've got here you've got 1 over infinity. So think about logs. So when you have something to the power of another thing, think about logs. So we are trying to find the limit of this. Let's just say the limit of this is the number y. Let's just say that. So let's just say the limit of this is the number y. So here we've got 1 to the power of infinity. So we've got something to the power. We've got one thing to the power of another thing. We should think about logs. Whenever that happens, we should think about logs. So now take the natural log of this side. Take the natural log of this side. That will then give you this. And then from here, the natural log, you can actually jump into here. So when you're here, immediately jump to here. Because when you take the natural log of this side, it's really you trying to find the limit of this whole thing here. And the reason why that's the case is because of this. So hang on, let's go back one step. We are currently here. Take the natural log of both sides. That will then give you this. Take the natural log of this. But the point I'm trying to make is that you can actually jump into here. So it's you trying to find the limit of this whole thing here. And the reason why you can do this is because of this. We've done this before in our section on limits. Suppose you're trying to find the limit of a constant times a function. So here, let's say you've got a function f of x, and then here you've got a function, a constant times a function. So if you're here, if you're at b here, f of b would be here. When you times c, it would jump to here. And then suppose you're here, when you times c, it would jump to here. Suppose you're here, when you times c, it would jump to here. So if you're trying to find out the limit of a constant times your function, rather than finding out the limit of this thing here, we would just find the limit of f of x. So find the limit of f of x. Once we've got our limit, so we would just concentrate on finding out the limit of our f of x. Once we've got our limit, we can just simply times c. So once we've got our limit, which will be here, we can just times c. That will then jump to here. So the point is that if you're trying to find out the limit of something complicated here, because it's a constant, you can take it out here. Well, this is very similar to this scenario here. You're trying to find out the limit of one thing. So let's say you've got that limit, and then you natural log of whatever that limit is. Well, that's the same as you trying to find the limit of this thing here. I hope you can understand this. Well, from here you can jump to here. You can jump to here. So now we are currently here. So we are trying to find the limit of this thing now. So you're taking the natural log of one thing to a power of another thing. So you can just simply move this down here. So that will then take you to here. So now let's try and now let's try and tidy this up. Here you've got a fraction times a block here. It gets multiplied to the top, giving you this. So now let's check. Put 0 into here. That will be this thing here will be 0, and then plus 1. Natural log of 1. Natural log of 1 is 0 times 10. So this will be 0. This top part here will be 0, and then put 0 into here. This will be 0 over 0. This is an indeterminate form, so we can apply L'Hopital's rule. So differentiate it. So visualize this as being a bubble here. Well, differentiate this. That will then give you this. Okay, and then differentiate this. That will then give you this. So now this gets multiplied to the top. So that will give you one fraction, 30 here. And then anything divided by 1, it just collapses down to that anything. So that will then give you this. Okay, so now remember earlier it was natural log. So now let me think now. Now as x tends to 0, this thing here will be 0. So you've got 30 over 1. So that's really 30. So now remember we are trying to obtain y. Because right from the start we said let that limit be the number y. So we are trying to obtain y. So we are currently here at the moment. So now e equally to both sides. That will then give you this. And then these two cancel each other out, giving you y. So y equals this thing here. Remember, right from the start we said let that limit be the number y. Well, the number y is this thing here. Okay?